SNS College of Technology. In the lecture series of steam nozzles, we have discussed earlier about the types of steam nozzles, what is the basic principle behind the steam nozzles and where it is applicable. So now we are going to see what is the exit velocity of the steam nozzle. Okay. So if you take a steam nozzle, so we will take an example, this is a steam nozzle. So this is entry and we will take this as exit. So at the entry we are assuming as 1 and the exit we are assuming as 2. Okay. So here what are the parameters involved in the entry is taken as 1. For example, if the steam entry with the pressure is taken as T1, temperature is taken as T1 and enthalpy H1 and then entropy S1. Same way, what are the values which are finding at the exit, it is considered as P2, T2 and then H2, S2. So these are the some of the properties. So other than that there are more properties. So now the steam nozzle is flowing inside. As we discussed in the previous video that it increases the velocity. So what is the main purpose is it increases the velocity. So here now the inlet velocity is taken as V1 and the exit velocity is taken as V2. Okay. Now we are going to find what is the exit velocity V2. For this we are going to apply the steady flow energy equation. Okay. So by the law of conservation of energy we know that energy in is equal to energy out. So energy in is equal to energy out. So based on this we are taking the equation as Zz1 plus half V1 square plus H1 plus P1 plus Q is equal to Zz2 plus half V2 square plus H2 plus P2 plus 1. So this is the general steady flow energy equation which is generally given. Here Zz1 is nothing but potential energy. This is potential energy, whereas half V1 square is kinetic energy, and whereas H1 is enthalpy, and P1 is flow energy, and this is heat. So this is taken as the input of the steam nozzles. And the right hand side same potential energy, kinetic energy, and then enthalpy, flow energy, but this input work is made here. So the input is given as heat, but at the output work is done. So heat is converted into work done. So this is the steady flow energy equation. So when this steady flow energy equation is applied for this steam nozzles, here what happens is, if you take the base, okay, if you assume a base and if you assume a center line, so this datum head Z1 and Z2 are same. So there is no difference in the potential energy. Therefore these two gets cancelled. Okay. Same way this flow energy also there is no change. And then here in the steam nozzles there is no heat is transferred. So it is 0. So no work is done. So all the parameters are get cancelled. So what is the exiting one is half V1 square plus H1 is equal to half V2 square plus H2. Now what we are doing is we are taking the enthalpy on the one side and the velocity on the other side. So if you take, so half V2 square minus half V1 square is equal to H2 minus H1. Okay, so we are taking here, so half V1 square and then we are taking on the velocities on the same side. Now here what happens is, let us write here, so half V2 square minus half V1 square is equal to, here if you take as H1 and then here you will take H1 minus H2. So H1 minus H2. Now this half can be common for both, it is taken. So now V2 square minus V1 square is equal to H1 minus H2. So now what we are doing is 2 is multiplied here. So therefore V2 square minus V1 square is equal to 2 H1 minus H2. Okay. So now we need the exit velocity, therefore V2 square is equal to V1 square plus 2 into H1 minus H2. So as this equation we need in kilojoules, we need in kilojoules, so we are multiplying by 1000, therefore V2 square is equal to V1 square plus 2000 H1 minus H2. So now we need the exit velocity, therefore we are taking root, therefore V2 is equal to root of V1 square plus 2000 H1 minus H2. So now what happens is, so the exit velocity V2 becomes root of V1 square becomes V1 plus root of 2000 becomes 44.72 and then root of H1 minus H2. So this is our equation for the exit velocity, which is derived from the steady flow energy equation. So to find the exit velocity of a nozzle, so this is the equation where exit velocity is equal to inlet velocity plus 44.72 into root of H1 minus H2. So what is H1 is enthalpy at the inlet, what is H2 is enthalpy at the outlet. Okay. So this is a small derivation on the exit velocity of the steam nozzle. Thank you.